Out here in the shop today, we're going to go over a couple things. I got a helper out here today. I don't know if he's doing me much good or not. Out here in the shop today, we're going to go over a couple. Hey, Saby. So this is a shop kitty. He comes out here, checks on the birds for me, looks out the window. So what did I wanted to go over? I'm going to lay up this bell crank, as you're probably bored already. But this is a prototype I dug out of the drawer over here. And this right here is half of the bell crank. So this is 1/16 of an inch. And I don't know if you can see it on the camera or not, but what I've done, I've glued these tabs on here to raise this up. And the next step, this is going to go on the bottom or the top, however you look at it. And this will be glued together. And what I'll do in effect is create a fork right here. It'll separate, so the bell crank will come out flat here, but then it'll rise up here. This might be flared. I might go in here with a little bit more epoxy, give it a nice gradual transition here. I don't like any sharp lines here where it has to transition, so I'll redo this, add material in here to get it a nice flare. And then the bell crank will be an 1/8 inch thick, and the fork, it'll have enough clearance in there for a button in your lead outs. So your lead outs will go on a pin that goes through here, and then it'll pivot this way on a button. And it's got to be probably a brass or something machine button that the lead outs will wrap around. If anybody out there has flown speed, that's the way they were doing their speed bell cranks. They put little buttons on them. So that's it in a nutshell. Basically, it's going to be flat on the bottom like the other bell cranks. And let's see if I can find one I had laying around here already cut out. What did I do with it? These are some that I've already molded. So here's one. Here's one that this is a standard bell crank. So in effect, it's going to be just like this, except for it's going to have a bump up here, and then it'll have a notch here for your button, the fork, and then the bottom will be flat just like this. So in order to make this bell crank out of carbon, obviously you got to make one of these molds. So what's got to happen, this has got to be molded into it, this fork. And this isn't the bell crank that's going to be used for anything other than making the molds. This is the master part. Now here's what I'm thinking. When I mold this, it'll be molded just like this bell crank. Just like this. So this mold will have the fork down in it here. So once I run this toe through there, I'll make a lap through there, a couple laps, and then I'll insert a plate that'll go here, and this plate will go over this tab. And it'll be UHMW or something that's going to release. So this plate will go right here where the fork's going to go, and it'll be bigger. It'll screw down here and here. So this plate will be molded into the whole process. And then what I'll do, the plate will be countersunk, so it'll be flush with this right here. It'll go halfway through the part. And then I'll keep laying up the composite part. And that's where this comes in here at the top. This will make it thicker. So this plate will come out once the bell crank comes out of the mold and the pins are pulled out. This plate will come out this way. Now this plate has got to be built up to where it forms a dam here. So as this mold, this right here will be the top of the mold, but the plate sits down lower. So in effect, when this plate goes on, this plate has got to be raised up right through here in order to form this, to dam this carbon up that's coming around this way. And that's the way that'll work. So in effect, it's a four-part mold. It'd be 1 part, 2, 3, and then the top will be the 4th. So I dug this out. I had this going, I don't know, maybe it was a year or 2 ago. I was working on it. So not only was I working on the shape of everything, the geometry, I had to work on how I was going to get it out of the mold with the fork in it. And here's how it starts before I come up with an idea to put it on paper. First thing I do is I come out here and just sketch it up. It's not on SketchUp, it's actually pen on paper. So I get the dimensions I want, and then I cut the blanks out. And eventually, you know, I gotta go through here and clean it up so it matches this. This was a C-temp piece that I made. These were precision punched holes. And once the C-temp was made off of this, then I transferred that to the phenolic. And then what I did is I just traced around it, one around there, and then marked where the holes need to be, and those were punched in there. And then cut it out, and let's just say you make this master part. So you glue all this together and you lay up a part and you think, you know what, it's a little bit too thick. It's I could take some weight out of it. And then you go through there and you can actually enlarge these inside holes, sand this down. And you can work this master part down to where you get it to where you want it. And then you start making a bunch of molds. So I'll probably make one mold, pull a part out, check it out, see how it's going to work. And if it's good, I'll make more. If not, I'll modify this a little bit. You can always make this smaller. You can make it bigger too, but it's a little bit more trouble. And probably use Bondo or something here for a fillet. Or that that epoxylite stuff, or that blue stuff. I can't even remember the name of it now. But anyway, you just form a little bit more of a fillet. So that's in a nutshell. That's basically what I came up with for a fork bell crank. And I was talking to an accomplished modeler guy that's at the top of his game. I won't mention any names, but it was Bob Hunt. And we sort of laughing. I told Bob all this rigmarole here for this bell crank. And he said, "Is it worth it?" I got to thinking, you know, I'm not so sure it is worth it, but it doesn't matter. I'm going to do it anyway. That's why they call it a hobby. So, anyway, so probably in the next month, I'll fiddle with the mold on this thing. And these little oil light bushings, I think I bought a whole bag of them at one time. I'm starting to run low. And if I can't replace this exact bushing for this, you know, the way these molds are set up, I'll probably find out what I can find that will do the same thing. It's the same size and weight. And I might have to modify the rest of the molds on a fork bell crank with this right here. So in effect, I mean, the fork bell crank I'm going to make up initially, it'll be a 4-inch bell crank. This was 9/10 of an inch, I believe. That was Paul Walker's number. This could be a possibility where I give you choices or something. You know, I don't know. I could put more than one hole, or so I don't know. I think right now it'll be this geometry, and then we're going to change this out here. It's going to have a fork. Now, I did some of this stuff, I don't know, last week where I was laying these things up. I'll go ahead and do another one. That'll get you good and bored. What I've done for the people that really weren't watching is I take a cup. These are two grams. And I've already got a little resin in here as an overflow from another cup. So since the cup is 2 grams and I want 10 grams of resin, I just set the scale on 12. And it's easy to overshoot this, and that's what happened the last cup I mixed. I overshot the amount of resin over 10 grams, and I had to end up pouring some out. So I'll just keep working it in there till I get to come up on 12 grams here. Now, you can mix up however much you want, but on these bell cranks, if I mix up 10 grams of resin, I still had a little bit left over, so you could probably go with less. I think you could probably mix up, get it down to maybe 8 grams. And then what I do for the curing agent, I transfer it out of the jug to this little eyedropper here. Shouldn't say eyedropper, whatever it is, little accordion squeegee. So 12 grams right now. I'm going to make it 15.33, and I just go 15.4. Let's see. And I might have to put more in here, but after you do a bunch of them, you get an eye for almost how much you need. And that and the reason why I transferred out of the jug, when you're making really small quantities of this stuff, it's too hard to pour that little bit of curing agent. It'll end up running down the side of the jug and get all over the place. It came out just right. There's 15.4. And that's 33% per hundredweight. It's 386, and what I've got in the cup for resin, it's an Epon 815. Epon 815. Let's see here. I got a lag in my viewfinder for my phone. So here's the resin mix. It's pretty water. Now this is redundant. Main thing I wanted to cover is just let you see that mock-up of the fork bell crank, and I'll talk you through the layup and how it's going to work with the fork. See how thin that is? It's really thin. If I had a viscometer, I'd be able to tell you how thin this is. You get this thing about 80-90 degrees, it even gets thinner than this. One of the things I like to do on these little parts with this little bit of resin, sometimes it's hard to get all the corners scraped out of it. Make sure it's mixed well. I take the acid brush, and each one of these I make, I get a new brush, and I just take the acid brush and I'll finish stirring this. So in effect, the acid brush will get down in the corners of the cup, and even sometimes up here around the lip. So that's where I want it. That's good enough. So to start out, this is it's got a surface coat in it. It's got a little black pigment. The black pigment, it was fiberglass. They sell pigments for epoxy. I was in Woodcraft a couple days ago, and they have a section in the back. It's around the stains, and what they have is a lot of epoxy for like casting tabletops, and they have colorants that you can actually add to epoxy. Some are metallic, some are like, oh, I mean, all kinds of neat stuff. And then they have the solid colors. And the solid colors, you know, basically the black, the green, the red. So you could go into that store if you needed some black pigment to do some parts. If you're going to paint them, it doesn't matter. But if you wanted a cosmetic part with a certain color, that'd be a good source. Go into Woodcraft or Rockler, and they have the stuff that's made for adding to epoxies. Some of the pen people that turn pens for a hobby, they've actually got little things where you can cast your own blank. So if you had a certain pen blank you wanted to cast, it's a little tray. It's built up at the side, and you pour your stuff in there. So one of the reasons when I put this gel coat in here, you can see how I come out from the mold. I do that on purpose because out here where there's no black, that's just PVA. And what that does, when you extend the gel coat out, it allows you to actually work your fingers in there and push and rub without the worry of busting through your PVA. So it gives you a little bit of a barrier on how rough you can be with packing this thing. So down in the button right here, I just take a pinch of this glass, or not glass, but the carbon. I dump that there, and what this does is fill up the button. The button really doesn't add any strength as far as the pull test would be, but it's, if you put this chopped carbon down in that indentation, it adds strength to the button on top, the little thing that rises up. One of the things I found out by doing these videos, if I do them on a Saturday, you get the most views. More people will tune in, being that they're home. There's certain times a day you can actually upload stuff, you'll get more viewers. And a weekend will get you more people to see it. And eventually, really, even after the weekend, you'll get more views overall. But me and the shop kitty, we don't worry about it. We're on our own schedule here. So I try to pack this chopped carbon towards flush with the top of the mold, or top of the trough there. Now when I do the forked end, it's going to have a little dip here where I'm going to mold in that fork, and there's not going to be any chop in there. It'll be just a regular toe. So what I do with this carbon, I split it, get it pretty close, and I try to pull it back to where when this carbon goes around this pin, it flares out a little bit. Let's see. I got 4 watchers. I had 5. One of them had to go back to work. So then I just pack this carbon in there. And this is the beauty of the gel coat, expanding past the cavity of the mold. You can rub your fingers around it without worrying about disrupting the PVA. And then this part here, don't be afraid to put too much resin, because you're going to see in a few minutes I'm going to be sucking this resin back out of here with a paper towel. This toe is starting to unravel a little bit on me. See where it's all it's been snagged on something. Straighten it out as I go. And if you get a few little curly cues, I mean, it's not going to hurt anything. You'll be alright. There's enough carbon in this mold to do what it needs to do. So as you can see, I sort of pre-wet it before I poke it down in there. One of the things you can do is roll it like this. It helps wet out quicker. And I get to the center post, I'll do a loop, 360 around it. Now this stuff's going to want to spring out of the mold, which is normal, don't worry about it. See where it's coming out, it's no big deal. Show you how to fix that in a minute. Each time you hit one of these pins, you do a 360. So you encapsulate that lead out. Now one of the things I'm not sure yet on this forked end bell crank, I've got to split the toe evenly from top to bottom. So the toe has got to go around one side of the fork, and then on the other side of the fork, when I mold it, it's got to go around the same amount of times. So right now with this carbon, I'm doing 3 laps, and then I use some chop around the, the button and stuff. When I actually do the fork bell crank, I think it's going to be one of these situations where it's going to be 4 laps, 2 on the top and 2 on the bottom. So I'm not sure where the weight's going to come out on the bell crank. Now obviously, if you have a forked bell crank, the chances of it becoming heavier are pretty obvious because you have more bell crank. So a 7-gram bell crank with a fork in it, I'm not so sure about it, but basically it'll be it'll still be light, probably lighter than any other forked bell crank, and then it'll also be strong enough. So it's showing I've got 5 watchers. So somebody chime in and say, yep, everything's good. That way I'll know I'm not talking into air here. Or you don't have to. So let's see. This will be my 3rd lap. So normally if I was doing the 5, or I mean if it's doing the 4 laps on the fork, I'm thinking 2 on the bottom, 2 on the top. The only way I could change that is if I change the dimension of this toe. Instead of this thicker toe, I could thin it down, get a different fiber count. The other thing with this 815, this resin I'm using in this the bell crank here, it works out good for wheel pants with really light glass cloth or carbon cloth. It's thin enough to where you get a really good wet out. It's strong enough, and the high temp properties allow you to get a really good part. Now this part here, when I come around the last time, this is my 4th layer right in here. As you can see, this stuff's swimming around. It's not packing down in there, which is okay. I'm not worried about that yet. Right now I just want to make sure that the carbon is fully saturated. And right now you can, if you look close enough, okay, yeah, Steve Berry said it's good, so hi Steve. So right now the carbon goes around these pins and there's little cavities in there. So what I do, take a little bit more of this chop, put it in there. Now some guys that do parts with a lot of sharp cuts or inside fuselage molds with inside corners that are pretty sharp, they'll actually take Cabosil and thicken the resin up, and then that resin and the Cabosil or chopped glass or flocks or whatever you want to put in there will actually take a sharp radius and add a fillet to it. And I guess in effect that's sort of what I'm doing here. I'm taking the sharp cuts in this mold, the corners, and then I'm packing it full of the smaller stuff here, which is this chop. And this really isn't, I guess it is structural to a small sense, but the chop makes sure you don't have any voids. Now, right now, the part's starting to lay down in the mold better than it was, but this right here, the carbon's still floating. So it's pretty resin rich right now. So the next step I do is I take some paper towel, and I think this sometimes will make or break a part, or make or break the part. I blot some of this resin out of this mold. Now you watch around here, if you can see or not see that resin come out. and I blot that up. And the more resin you blot out of this mold, the stickier it gets, and the more the carbon wants to stay down in the mold. So you got a part that's compacting better. Your strength goes up because the ratio of carbon is on par with the resin. And as you roll your thumb across this mold, you can just see that clear resin come out of that carbon. And then you can pack the carbon back down in there. So the carbon gets drier and drier, but it's still wet enough to do what it needs to do. And this is where you get a really good part. And this is what I was talking about before. If you have the that gel coat come out of the mold, you're able to do this. You're able to work your thumbs down in there and smash it. And I just keep positioning the carbon so it's down in the mold. Now I just finished a gear mold for it's like an RC Funfly plane. And some of it is on Sparky's where I demolded it on his stun hanger. You guys might want to look that up. I'll get with him later to do some more stuff. So by looking at this side versus this side, you can see how this is starting to lay flat. And this side's still puffed up because it's too resin rich. So I'm going to go do the same thing on this side. And you can sometimes hear, air bubbles pop out of this thing. And that's a good thing. So I just keep working the carbon, kneading the carbon until the resin starts to come out of it. And then let's just say you're going through here, you're pulling out the excess resin, and it gets a little dry, or you got some voids and you need more carbon, just get your brush, put more carbon, chop, toe, or whatever you got to do to make it work. So this thing's in flux here all the way up until you put the top plate on and clamp it. So, and there's enough work time, 20 minutes for this size of part leaves you plenty of time to work it. And if you're making parts that are structural, where it actually has to do something as far as structure, you got to get it right. Now, if you mess up on a wheel pant and it's sitting out there floating, it's all cosmetic and there's air bubbles or something, it's not going to hurt anything. You just fill it with primer or whatever. But obviously a structural part, I guess, has got to be structural, right? So it'll be interesting to work on that mold for the yeah, Greg Meyer. He said he's at work. So it'll be fun coming up with something new. I'm sure the fork bell crank, there's gonna be some gremlins pop up when it comes time to actually make the part, not only the mold, but the part too. So as I pack this down in there, I think I've got almost all the excess resin coming out of it. And I can just see just a few little spots that I can put just a little bit more chop. The danger is if you get too much, pack it too tight, then obviously the mold doesn't go together as tight as it should. So I'll just put a teeny little bit more of this in here in a couple places. Add a little bit more to my brush here. Now obviously, if you're going to do something really quick, I'll back up. One of the things, if you're making parts, doesn't matter what it is, if there's always a better, quicker way to do it, a lot of times it's a more expensive way. And so it's more expensive, but it's quicker. So it's a trade-off between you've got more expense in the process and the time it takes to make it, but then you've got less labor in it. So you have to figure out, okay, so if I spend X amount of dollars, is it going to be a break-even proposition because I spent more on the process and the materials to save the labor? And it's a pretty no-brainer if you don't have any more time to spend on a part. You've got to get the time down. There's only so many hours in a day. And what I'm getting at here, take a part like this bell crank. Let's say I'd go out and I'd get this machined out of stainless steel, the mold, and it was precision. I mean, the fork, the plates, everything perfect, all the way down to the 10th of a thousandth. And then I go out and I buy pre-preg toe, and what that is pre-impregnated, where you're not actually adding resin to the toe. So this bell crank would be machined in the mold, and it would be perfect. It would be a perfect match to the amount of pre-preg you're putting in there. So instead of going through all this process here that you're watching for 20 minutes, you'd snip off a piece of pre-preg, 2, 3, whatever it is, the length, and you'd press it down in the mold. It'd already have the resin, and then you put it in a hydraulic press, heat it up, and an hour later you pull the part out. Sometimes I've even seen carbon pre-preg in sheet form, like woven. They'll put it in a press and it comes out within a minute. It's huge amount of pressure on probably a huge amount of heat, 250, 300, and it goes really quick. The question is, okay, so you cut out all the labor, you're making them really fast, but it's a trade-off. And I always got to the point with this stuff for model airplanes, and I've looked at the trade-off thinking, you know, I can go out and I can do all this different stuff that's going to speed it up, but it's going to cost. And I was always afraid whether I could recoup it. Now, another good example is, and it's hard to tell because things keep moving faster and faster. Let's say you're a big propeller manufacturer and you're making props and composite props. And there's been a few of them out there that were making props sort of like this out of carbon fiber toe. And every prop you make goes on either a gas engine or a glow fuel engine. Now all of a sudden, the people who were buying those composite props were all flying competitively, most of them, and now they're flying electric. So that means every mold, every prop that you made is now basically obsolete. So you have to reinvent everything. Now APC, they were smart to where they just fire up another computer program and start kicking out another design. I bet you they can go from the CAD software to molding in probably a day or two. But they got to have a huge volume. So as you can see, the little chop, it's laying nice and flat. And here's one of the things that surprises people when I do this. So I get all the resin out of it, just like I did. And this is the plate that's going on the top. And the last thing I do before I close the mold, I put just a little clear resin in here. and especially right here in the center. And basically I soup it up just a little bit, usually no more than that. That's good enough. And then I immediately cap it. Now this is UHMW with a coat of wax on it, and that's it. And then I'll clamp it. So the people that are east of the Mississippi, you're probably familiar with Menards, and this is that Master Force brand. I went into Menards with my rebate, my 11% rebate certificate, and I got a whole bunch of these clamps. These clamps, this clamp here, it's a 12-inch clamp, perfectly straight, machine good. I mean, it's nice. 11 bucks. Now, I'm not saying you can't go to Harbor Freight and buy them cheaper. I'm sure you can. But I thought at one time I was buying clamps at Harbor Freight, and I'm thinking, well, how bad can that be, right? So I buy these clamps at Harbor Freight, and, you know, I mean, they're clamps, right? So I get them home and I start using them, and the holes here weren't even drilled square. So when I put two clamps side by side, my handles were touching because this hole wasn't tapped straight. So 11 bucks a clamp, and I went into Rockler and they had a Bessie clamp, exact same clamp. I mean, as far as dimension and everything, obviously the casting was different. It wasn't any better than this one. It was $34 for a clamp. And that's 3 times as much. So if you're east of the Mississippi and there's some Menards around, go in there and take a look at them. I like these bigger clamps than the ones I was using because I could put a lot of pressure on them. They say it's I don't know, 1,000 pounds of force. Now I don't know if this matters or not, but in this casting it says DIN 5117. So I don't know if that means anything or not. But basically it's a 12-inch clamp. Now I can't imagine needing anything deeper than 12 for our stuff that we do for hobbies. But woodworking and stuff, you know, I bought longer clamps. But the problem is you can use long clamps on this, but you got so much hanging out. It makes it a little bit more cumbersome. So after mixing up that resin, mixed up 10 grams. So that's what I got left over. So let me weigh this. Let's see how much resin I actually used. Let's see where I'm at. Okay, right now the cup and the resin is 6.5 grams. So the cup's 2. So that means I've got, of course, who knows what I got on the brush. Basically 4 grams of resin in this mold. 6, yeah, 4. No, I've got roughly 6 grams of resin. So anyway, of course all the waste and the drip, but out of 10 grams of resin plus the 2 of the cup, that's what I got left. Now what you can do, if you think ahead, take your extra resin and get a bunch of molds ready for like wheel pants or something. And then the leftover resin you got right here works out really good to do a surface coat because it's a little bit thicker, not as runny. And then, can't really see it, but I got a hot box in here that I cure these molds. Let's see if we can get a shot of that.